Welcome to video S13. In this video, we're going to talk about exact values from these familiar triangles. So our learning goal is to use these special right triangles to find exact ratios for sine, cosine, and tangent. And these special triangles, you can just see them up here. Our first one is the 30, 60, 90 triangle. So all this means is they're all going to be right triangles. 30, 60, 90 just says we have a triangle, that, so we have a 30-degree angle and a 60-degree angle, and then obviously the 90. And then our second triangle is going to be 45, 45, 90. So it looks kind of like this. So again, there's the 90. And we kind of make this base angle 45, which leaves triangle theory 45 up there as well. So we're going to use those, and we're going to attack those with our right angle trig skills from previous courses, Math 10 with SOHCAHTOA. All right, so we know that sine of an angle is opposite over hypotenuse, cos of an angle is adjacent over hypotenuse, and tangent of an angle is opposite over adjacent. So that's our kind of goal for today. So we're going to start with our 30, 60, 90 triangle, right? So 30, 60, 90, we're going to use that to find, it looks like a lot, sine, cos, tan 60, sine, cos, tan 30. Okay, looks like a lot. It's actually not bad. So let's get this one started. So I'm just going to start by drawing my triangle. I'm going to try to make it big because it's going to be useful for the whole question here. Try to make it a little more accurate too, like that. Okay. So as I look at this, so I have a 90-degree triangle, and then I'm going to make it a 30, 60, 90 triangle. This actually doesn't matter which way oriented. I'm just going to say that's the 30 and that's the 60. And actually might, I'll color code this a little bit. So I'll make the 60 purple. Okay. And then we're going to fill in the sides. So we kind of know these sides 1, root 3, and 2. As we kind of like build this up, we know amongst these sides, I know 2 is the biggest number, so that's going to be the hypotenuse in the special triangle. The root 3 is going to be opposite the bigger angle, so the 60, and then the 1 is going to be opposite the smaller angle. Now, we've talked about how to kind of make those in class, so feel free to kind of go back there and kind of see how to make that triangle, but that is our special triangle. Once we have that set up, it's pretty straightforward. Is all we're going to say is, well, okay, let's look at the 30 first. So I know from the 30 degrees, the 1 is the opposite, the 2 is the hypotenuse, and the root 3 is the adjacent, right? So sine 30, I know is going to be opposite 1 over hypotenuse 2. So sine 30 is 1/2. Perfect. Cos 30. Cos 30 is going to be adjacent root 3 over hypotenuse 2. And then tangent 30 is going to be opposite 1 over adjacent root 3. And then what I would do is I would immediately rationalize that. So root 3 over root 3, which gives me tangent 30 is equal to root 3 over 3. Depending where you are, if you haven't seen the rationalize, don't worry about that. 1 over 3 is correct. But yeah. Okay. Next up is going to be the 60s. So the 60s, we're going to say, well, okay, so sine 60. From 60 degrees, well, in purple here, this root 3 becomes the opposite. The 1 becomes the adjacent, and the 2 remains the hypotenuse. Right? So sine 60 is going to be, well, opposite, which is root 3, over hypotenuse, which is 2. Cos 60 is going to be equal to adjacent, which is now 1 over hypotenuse, which is 2. And then finally tan 60, which is going to be, so from the 60, the opposite, which is root 3 over the adjacent, which is 1. I almost mixed up my colors there. So root 3 over 1, which is just root 3. So there's your 3 60s. Notice that kind of between the two, cos 60 and sine 30 are the same. Sine 60 and cos 30 are the same. And then tan 60 and tan 30, they are reciprocals of each other. but those are the 6. Yeah, so if you need to pause that and kind of take another look at that, that's good. Like there's a lot happening here. But I'm going to pull up the next, the one for you to try, just to kind of finish off these triangles looks. So here's yours. You're going to use this second triangle, the one kind of right up here, and you're going to use that to find sine 45, cos 45, and tan 45. So pause the video, take a shot at that, and then we'll come back for the answer. Okay, welcome back. Just kind of going through this one now. So there's the answer. So you can see sine 45, cos 45, tan 45 up there. Sine 45 and cos 45, notice, so they're just the same value. And then tan 45, opposite over adjacent, well, they're the same if it's a 45-degree angle, so tan 45 is 1. So altogether, what that gives us now is if I kind of zoom out, we have a pile of really important values right now. So we have sine 30, cos 30, tan 30, rationalized, sine 60, cos 60, tan 60, sine 45, cos 45, tan 45. And the nice thing is there's a bunch of relationships in here, right? So like we said above, sine 30, cos 60 are the same, sine 60, cos 30 are the same, sine 45, cos 45 are the same, right? So it's 9 values, but there's really not that many kind of independent values. So the last question we're going to attack here is what if it's not an angle that's like a 30, 45, or 65, or 60. So here's your last one. So what about cos 120 and tan 225? So let's just like set these up and take a quick look at them. So cos 120. What I'll do to start is I'm just going to kind of take a really quick sketch of this thing. So cos 120, I know 120 is in the second terminates in the second quadrant when it's drawn in standard position. So it looks like this, right? So what I want is that reference angle. Well, the reference angle is going to be 60 degrees back from 180, so it's 60 degrees. So what that does is that kind of, I can use that triangle to kind of like use, okay, so cos 120 is going to be basically the same as cos 60, but I'm in quadrant 2, so therefore cosine is negative. So what I'm going to say is, well, okay, so cos 120 is going to be equal to negative cos 60. And remind ourselves what was cos 60. Cos 60 was 1/2. So cos 120 is equal to negative 1/2. So cos 120 is equal to negative 1/2. Done. Zoom out a bit to get tan 225. Change colors here. It's going to be the exact same idea. So tan 225. So 225 is bigger than 180, so it's at least quadrant 3, and it is quadrant 3 because it's less than 270. So tan 225. So 225 is that angle in standard position. So again, I want this reference angle. I can clearly see I'm going back to here for my reference. So how far past 180 is 225? 45. So 45 degrees. So what that does is that gives us, again, that triangle. So what this is saying is, hey, tan 225 and tan 45 are very related. Because I'm in quadrant 3, I know cos and sine are both negative, which means tan, the ratio of those two is also, it's going to be positive, right? Because negative over negative is positive. So tan theta is positive. So what this tells us is I know the reference angle was 45. So tan 225 is going to be straight up just equal to tan 45. Tan 45, if you look, it's right there. You can see it was 1. So tan 225 is also 1. And that's it. I circle them both. And that's it. So that's kind of like, this is the core of the unit circle, which could create, but yeah, this kind of shows the symmetry and those kind of the relationships between the 3 ratios, sine, cos, and tan. Final checklist there you can see at the bottom. So if you were making these kind of by hand without the unit circle, choose your triangle. So which triangle do you want? 30, 60, 90 or 45, 45, 90. Label the opposite adjacent hypotenuse. Use your right angle trig, SOHCAHTOA, and then apply the quadrant sine and reference angles for standard position angles. And that's it. Thanks for watching.